Very good. So let us move on to 5.5. Our objective is to factor a trinomial. Very well. So what we learned so far? Recall that a trinomial is actually a polynomial with only 3 terms. Is a polynomial with 3 terms. Okay. 3 terms. In general, we can write a trinomial this way. X squared plus bx plus c. Note that here you have exponent 2, so the degree of this trinomial is equal to 2. The degree is equal to 2. The leading term, remember that, the term with the highest exponent was our leading term. Leading term is equal to ax squared. Well, remember what a is? A is the leading coefficient. So leading coefficient is equal to a. These are the things that we learned before. So now we're going to start to factor out a trinomial of degree 2, ax squared plus bx plus c. The very first case is that your leading coefficient a is equal to 1. So this is our case 1. A is equal to 1. So in this case, your trinomial is actually x squared plus bx plus c. How do we factor out this trinomial? Very well. In this case, we usually write this trinomial of degree 2 or this quadratic expression as the product of 2 quantities. The first quantity has x plus a constant. The second quantity also has x plus a constant. So our goal is to find these 2 constants or these 2 numbers. What goes here, what number goes here, and what number goes here? What are those? How do we find those numbers? Very well. Note that you have exponent 2. If you multiply x by x, it's going to be x squared. X times the number plus x times another number plus that number times the last number is actually equivalent to x squared plus bx plus c. So you're looking for 2 numbers that their sum, their addition is equal to b, and their multiplication is equal to c. So it means that we have to do a little bit of algebra and try to find those 2 numbers. The product of these missing numbers is equal to c, and their sum is equal to b, or the coefficient of x. The sum of these missing numbers is equal to, well, let us go over one example to feel more comfortable about the process. We know how to find those numbers, but show us one example. So for those of you who are following the book, we are on 339. So let's go over one example to feel more comfortable about this. Here you have x squared. Our first example says, factor out completely. Factor what? Here we have x squared minus x minus 12. Okay. Let us take a look at our trinomial or quadratic expression. This expression is actually written as x squared plus minus 1x plus minus 12. Compare this with the quadratic expression or this trinomial written in general form. Here we have x squared plus bx plus c. So what is our b? B is -1. What is our c? C is minus 12. Well, b is equal to -1 and c is equal to -12. We want to write this in factor form. What's the meaning of that? It means that we're looking for two quantities that when we multiply them together, we get this quadratic expression back. Well, this is equal to, so as we know how to follow, we have two expressions multiplied together, x plus a number, a missing number, x plus another missing number. Okay. The multiplication of these two numbers is equal to c, and their sum is equal to b. So first box times the second box is equal to your c. What is c? C is -12. And if you add these two boxes, the outcome is equal to -1. So we're looking for these two numbers, missing numbers. Think about it. You have the product of two numbers to be a negative number. It means that either the first one is negative or the second one is negative. You have 12. 12 is the product of, very well, 1 and 12, 12 and 1, 1 and 6, 6 and 1, 3 and 4, 4 and 3. And remember that we have a minus sign, so one of them is negative. There you go. So let me list all of these for you, all the possible multiplications. Let me find my other marker. So -12 is equal to, -12 is equal to -1 times 12, or it is 1 times -12. -12 can be written as -2 times 6, or it can be written as 2 times -6. -12 can be written as -3 times 4, -3 times 4, or it can be written as 3 times -4. Do we have any other possibilities? I don't think so. That's it. So we found two numbers, the product is -12. One of these options. We have the second condition. Know that if you add these two numbers, their sum must be equal to -1. If you add those two boxes, the sum is a negative number. What number? -1. So let us check each of these one by one. If I add 12 and -1, the outcome is 11. Do you have 11 here? No. So this option is not a correct option. How about the second one? You have 1 minus 12, which is negative 11, negative 11. I'm looking for negative 1. Is this option possible? No, unfortunately not. How about negative 2 and 6? If I add 6 and negative 2, I get 6 minus 2, which is 4. I'm not looking for 4. I'm looking for negative 1, so not a good option for me. How about 2 minus 6? It is negative 4. Again, I'm looking for minus 1, negative 1. So this option is not good for me. How about this one? 4 minus 3. It is 1, but it is positive 1. So negative 3 and 4, no, it's not a good option for me. Finally, 3 and negative 4. 3 minus 4 gives me minus 1. This is the option that I'm looking for. So what are these missing numbers? 3 and minus 4. 3 times minus 4 is negative 12 if you multiply them. And if you add them together, the outcome is negative 1. So these missing boxes, one of them is 3, the other one is negative 4. The order is not important. So x plus 3, x plus minus 4, which is x minus 4. This is complete factorization of this trinomial into the product of two linear expressions. Remember that you can always check your factorization by multiplying these two expressions. Check your work. Check. How do I check that? I need to use FOIL method or distribution. I have x plus 3 times x minus 4. My goal is when I multiply these two expressions, I get this trinomial back. So x times x, we get x squared. X times minus 4, minus 4x. 3 times x, 3x. And x times negative 4 gives me negative 12. Remember that these two middle terms are like terms. What's the meaning of that? It means that I can add them, I can subtract them. This is equal to x squared minus x minus 12. Do I have my original expression back? Yes. What's the meaning of that? It means that this is a correct factorization. Let's go over another example to feel more comfortable about this process. Very well. So in this example, we have a different free variable. Our free variable is actually p. Here you have p squared minus 7p plus the constant 6. What is our goal? Our goal is to factor this completely. Very well. How do we do that? First, we're going to write two linear expressions, and we're going to copy down our free variable plus a missing value, free variable, independent variable p plus the second missing value. Very well. Okay, so we're looking for two numbers. We're looking for two boxes. Let us write down box. One box here, the second box here. We're looking for two missing numbers such that if you multiply these two missing numbers is equal to your C. What is C? C is 6. And if you add them together, the sum is equal to minus 7. Very well. So the multiplication of two numbers is equal to 6. Their sum is negative. Okay, let us try to investigate what are those two numbers. The product is 6. 6 times 1, of course. 1 times 6. I expect you to ask, the outcome is positive. Why we don't multiply negative numbers? Remember that negative times negative is always positive. Minus times minus is always a plus. So I can have minus 6 times minus 1. Also, why I wrote 1 here, I don't know. 6 times 1, it was 1 times 6. So negative 1 times minus 6. Very well. What else? You have 2 times 3 and also 3 times 2. Of course, you can write it as the product of negative 2, negative 3, the product of negative 3, negative 2. So you have 1, 2, 3, 4, 5, 6, 7, 8 options, and you can quickly eliminate 4 of them. Why is that? Because the sum, you know that the sum is a negative number. So you can quickly say that, hey, the sum of all of these is a positive value. I'm looking for a negative value. So I'm going to just ignore these 4 options. Okay, negative 6, negative 1. Of course, the multiplication is equal to positive 6. What if I add these two? Negative 6 minus 1 is negative 7. Well, I'm so lucky. I found this. What about this? If I change the order, negative 1 minus 6 is also negative 7. But these two numbers are the same. We just change the order. How about these two? Negative 2 plus minus 3 is negative 5. As you can see, the outcome is not negative 5. So this is not the option. Negative 3 minus 2 is negative 5. Again, you get negative 5. So note that we just change the orders. So what are those two numbers? You can write it as negative 6, negative 1, or negative 1, negative 6. That's why I said the order is not important. So the answers, we can write it as negative 1, negative 6, negative 1, negative 6. So you have p minus 1, p minus 6. We can check our work. Check our work. Check. By checking, it means that we are multiplying this back and get to the trinomial itself, the quadratic expression, the expression with exponent 2. Very well, I have p minus 1, p minus 6. So p times p squared, p times negative 6, minus 60, negative 1 times p, negative p, and negative 1 times negative 6, positive 6. Do we have like terms? Do we have similar terms? Negative 6 minus 1 is negative 7. I have negative 7p. So this is going to be p squared minus 7p plus 6. Do I have my original exponent? Do I have my original p squared? Yes. Do I have my original linear expression? Yes. Negative 7p. Do I have my original constant? 6? Yes, of course. So it means that the factorization was correct from the beginning. Let us make it more interesting. So in this example, we want to factor out this polynomial completely.